So, good afternoon.
Good afternoon.
So, today we have to discuss about optical fiber, isn't it? So, in the experiment, we determine the numerical aperture and acceptance angle of the optical fiber, isn't it? See, first we know about it. What is optical fiber, isn't it?
Yes, sir.
Did you know optical fiber?
It's a technology which uses a glass fibers to share informations in a light pulse or photons.
Super. See, so now we discuss the diagram of optical fiber. So in that optical fiber having this is the jacket, isn't it?
Yes, sir.
Okay, and this is the buffer, gladding, and in the inside of the gladding we have a core
Which contains
the
glass
glass fibers, isn't it?
Yes, sir.
And this optical fiber consists of two types, isn't it? One is the single mode, isn't it? Another one is the multi-mode. Yes. So what is single mode? Do you know?
Single mode is used to transfer data in high speeds. It is used to transfer data in long range.
Super. And what about multi-mode?
It is used to transfer the data from a shortest distance.
Isn't it? It is in that multi-mode. The light carries the multiple rays.
It carries multiple
rays. And a single mode is the
It carries
only single rays, isn't it? And then the size is the 9 microns, isn't it?
Yes.
And what is the principal?
Total internal reflection.
Total internal
Reflection.
What is total internal reflection?
So, when light
Critical and
in less than critical, when light passes less than critical angle, the light gets reflected inside the optical fiber, so that information is passed to the long distance. If the light is sent into a optical fiber above the critical angle, it gets diffracted and go away from the optical fiber, so that information cannot be passed.
Super. That's it. And what are the applications of optical fiber?
Applications which involves telephone communication and CCTV cameras in medicine and telephones, etc.
Super. See, so these are the optical fiber. So in that fiber we determine the how to light transmit one end to another end, isn't it? So we need what is numerical aperture and acceptance angle, isn't it? See, acceptance angle means the maximum angle down. Is that maximum angle? That maximum angle means incident, isn't it? It influences that total internal reflection, isn't it? And what is numerical aperture? Any idea?
Sign of numerical aperture.
Sign of the
Numerical
aperture. Super. So in the numerical aperture having no unit and acceptance angle is a degree, isn't it? So now we start the experiment, isn't it? It's a simple experiment. See, this is the fiber optic light source, isn't it? And this is the, what is this?
Table. Stand, sir.
Stand. And this is the screen. In the screen we have so lot of circular spot. So each spot having a diameter, isn't it? In a millimeter, isn't it? First spot is that 5 diameter. Second one is the 10, 15, 20, 25, 30, isn't it? And this is the source. Okay, one. See, so now switch on the light source. The light fall on the screen, and you have to focus on the each circular spot, isn't it? Like this. So this is the first circular spot, isn't it? And you can measure the distance between screen and source, isn't it?
Yes, sir.
Did you understand that?
Yes, sir. Sure.
So now I focused first spot, and the distance is 0.2. Note it. The distance between screen and 0.2. So in that scale is a centimeter and you have converted to meter, isn't it? 0.2 into 10 power minus 2,
Minus 2.
isn't it?
Yes, sir.
And second column is the radius of the circular spot. So already we know that first circular spot diameter is 5.
5.
So therefore radius is
2.5.
2.5 into 10 power minus 3 meter,
Done.
isn't it?
Yes, sir.
And we have to continue on that second, third, 4, 5 and 6,
6.
isn't it?
Yes, sir.
So now I calculate numerical aperture for first one and then you have to find
Fine.
remaining,
Yes.
isn't it? So where is the calculator? So okay. So first we find a numerical aperture. R is that 2.5 into 10 power minus 3 and D is that 0.2 into 10 power minus 2 meter,
Yes, sir.
isn't it?
Yes, sir.
So we have a formula NA is equal to R divided by root of R square plus D square, isn't it? So we have the known values or 2.5 into 10 power minus 3 divided by root of 2.5 into 10 power minus 3 whole square plus 0.2 into 10 power minus 2 the whole square, isn't it? And we got the answer is 0.678, isn't it? So the remaining values you have to find the numerical aperture,
Yes, sir.
and finally you get a 6 numerical aperture, isn't it? You have to take mean value of numerical aperture,
Yes, sir.
and then you have to put the value in the acceptance angle theta max equal to sine inverse numerical aperture, isn't it? And we get some angle, isn't it? Well, for example 42 or 48 or 58 like this, isn't it? Did you understand that?
Yes, sir.
Yes? Thank you.